Okay, we're going to do a little review of all this fun stuff. So hopefully you tried it out first, and then you can watch the video. Alright, let's go. So free body diagrams are 4 situations below. The net force for each one is known for each one. However, the magnitudes of few individual forces are not known. Determine the magnitude of the unknown forces. Alright, so let's look at A. Now, since force net is 0, everything has to cancel out. So A is 50 and B is 200. So fun. Now, net is 900 up, so that means that C has to be 1100, because 1100, take away this 200, will be netted a 900 up. Okay, force net 60 to the left. Alright, so 60 that away, which means that D is going to be 20, because it has to take away this from there. And E is going to be 300, because it's got to cancel out the upwards one. Alright, so 30 newtons to the right. So that means, well, I'm going to do G first so I don't have to remember this. So G is going to be 50, because you got to take away 20 and you have to be left over with the right stuff. So F is going to just equal H, whatever H is. It doesn't matter. Hopefully you didn't get too confused. Alright, let's do some more. We're not going to do all of them, but we'll do a smattering of them. The rightward force is applied to a 6 kilogram object to move it across a roof surface with a constant velocity. The object encounters 15 newtons of frictional force. Use the diagram to determine the gravitational force, normal force, net force, and applied force. Okay, so we have a constant velocity. That's important too. Alright, so what do we know? We know that the force of gravity is just going to be 6 times 9.8, hopefully, which is going to be 58.8 newtons. 58.8. We also know that it's just a horizontal rough surface, so this is also going to be 58.8. Since it's a constant velocity, that means there's no acceleration. Oh, I told you the mass. So this is going to be 15 newtons. So the F net is going to be 0. Perfect. Alright, jumping over to number 4. A 5 kilogram object is sliding to the right and encountering a friction force, which slows it down. The coefficient, mu, between the object and the surface is that. Determine the force of gravity, normal force, friction, and all that other stuff. Okay. So, what was it, 5 kilograms? Yeah, so 5 kilograms, so that means the gravity force is going to be 49 newtons. Now, we don't have a slope, so the normal force is also going to be 49 newtons. Alright, since mu is 0.1, that means the force of friction is going to be 4.9 newtons. Ta-da! So, how do I figure out acceleration? We're going to use this formula. Have you ever seen this formula before? So we're going to have 4.9 is equal to 5 times A. So what's A going to equal? Ooh, mystery. Divide by 5, and it's 0.98. Weird, isn't it? So what's the net force? The net force is 4.9, because that's the only force that's not canceled out. Alright, cool. I think we got some more. Jumping down to number 8. An object is accelerating at 2. If the net force is tripled and the mass is doubled, what is the new acceleration? Good question. Alright, there's, you could reason through it, but I like to use math here. Have you ever seen this formula before? So I know that A is equal to F over M, right? Just divide both sides by M. Now if I triple the net force, so I'm going to have 3F, and the mass is doubled, divide by 2M. Right? So this is what I'm working with. What this is going to equal is it's going to equal 3 halves times F over M, right? Now F over M is equal to A. So it's going to be 3 over 2A. So I'm going to have 3 halves, or 1.5, times whatever the... Oh, we know the acceleration. The acceleration is 2. So I'm going to have 3 halves times 2, which is equal to 3 meters per second squared. Alright, an object is accelerating at 2 if the net force is tripled and the mass is halved. Alright, same kind of idea here. So we're going to triple the net force, and we're going to have 1/2 the mass. So if we split it apart, it's going to get 6 times A, and A is 2, so this is going to equal 12 meters per second squared. Nice. Bob must exert 240 newtons of force on a 980 kilogram car to move it at a constant speed horizontally. Can he do it? Yes, he can. The frictional force is 240. What is the acceleration of the car if he exerts 350? Well, let's draw a picture. Here's the car. It's an import. So if he's pushing this way at 240, no, sorry, he's not pushing at 240 anymore, he's pushing at 350, and the frictional force is 240, and it has 980. So how do we figure out the acceleration? We use this formula, F is equal to ma. Have you ever seen it before? So this is going to be 110, because you subtract them, they're going opposite ways, equals 980 times A. So A is going to equal 110 divided by 980, so 0.11 meters per second squared. What is the acceleration of a 6 kilogram object hanging on a string that is under a tension of whatever? Alright, so this is 6, so the force of tension is going to be 80. Well, what's the force of gravity going to be? So it's going to be 6 times 9.8. So it's going to be 58.8. Well, so we're going to do F is equal to ma again. Have you ever seen this formula before? So we're going to have 80 minus the 58 number, which is 21.2, is equal to m, which is 6 times a divided by 6. So we're going to get 3.5 meters per second squared. So fun. What tension would accelerate a 5 kilogram object suspended on a string upwards? Okay. So we're looking for the force of tension. Since this is 5, gravity is going to be 49 newtons. Well, I know that Ft minus 49, which would be the net force, is going to equal m times a, right? F equals ma. Well, here, F is equal to ma. Have you ever seen this formula before? So m is 5. Upwards at 6.2 is going to be 6.2. So solving for this, I'm going to have 5 times 6.2, enter, plus 49, enter, which is 80 newtons. What about downwards? So it's going to be similar idea here. Ft minus 49 is equal to 5, but this time your acceleration is going to be negative. Okay, because your acceleration is pointing the same way as gravity, so it's got to have the same sign. So 5 times negative 6.2 and then plus 49 is equal to 18. This should make sense, because if you want to pull it upwards like this, you're going to have a stronger force of tension than to just let it slide downwards. Hopefully that makes sense. If I didn't do your favorite question, well, here's all the answers in case you didn't notice it at the bottom. Hopefully, if you didn't get one, let me know and I'll help you out if I can.